Well, hi guys, it's Lee here. Just thought I'd do a quick video as it's well, almost halfway through autumn now, and winter's knocking on the door very soon, I'm sure. I just thought I'd explain how snow, although how difficult it is to forecast snow here in the United Kingdom, because obviously many of us probably know from experience that some places get snow heavier than others, and other places miss out. And we often wonder why this is the case. Well, there are many factors to take into account, but there are three main ones that I want to explain for you in this video. And the first one is the upper air temperatures. This is the 850 HPA upper air temperature chart in front of you there, and you see it's represented by different colours: greens, dark blues, light yellows, dark yellows and dark reds. What we're looking at here are lines around here. These lines here are isobars, obviously isobars even, and on the lines you can see these black lines here. There are numbers on. Now these numbers represent the upper air temperature, which is way above in the upper atmosphere, and what we're generally looking for here is the -5 isotherm, which is what it's called here, and as you can see it's wriggling around there just to the east of Greenland. That's the -5 isotherm. If you're within this, then snow is very possible. There are two other factors that I'm going to explain in a moment, but this is the first one I'm looking at today, and it's the isotherm line here. Or should I say at the moment, I should say. So this would need to be right over here, really, to be honest, coming down across the UK. At the moment, obviously, it's up here. This is Monday, the 22nd of October, actually. So winter's a long way north at the moment. This is autumn over the UK here. This is the jet stream line just here over the UK. So it's the -5 isotherm is what we would need to be covering the UK. So sort of where this line is here, if you imagine that northwards here. The second factor is the thickness. Now this is the thickness of the atmosphere. When we say thickness, the thicker the atmosphere is, the more moisture and the warmer the atmosphere is. Hence in summer the atmosphere is much thicker, much more humid, and that's what causes humid, sticky, hot days sometimes. Not so much of that this summer, but certainly over many summers in the past. But the thinner the thickness, then obviously the colder the air will be. Hence, as you go up a mountain, for example, the air gets colder and the air gets thinner. Therefore, the oxygen becomes much less for us human beings. So this is very thin outer atmosphere air here, because we're looking at the 528 line, which is represented just here. If you see it just there, it's that light blue line. As you can see, this is again dated the 23rd of October, a couple of weeks away. So there you see it's way up over Greenland here, as Greenland's now in winter now. So this is where the ice is beginning to reform again. It's behind the 528 line. If we go behind the dark blue line, which is the 510 line, which is something we very rarely see coming south over the UK, that will bring us bitterly cold weather, seriously cold Arctic blasts that would be, but that's very rare. The 528 line is the one that does sink south during the winter from time to time. Of course, this cuts off the jet stream when this moves south, because colder air is much denser air. So it does cut off the regular flow. This is the jet stream, just out of interest, running across the Atlantic here. So the jet stream is just there, the polar jet, at this present time. So that's the 528 line we're looking for there. So if you've got that, and you've also got the -5 line, wouldn't guarantee snow, because we still need a third factor in this. Is what I really regard the most important one, really, is the dew point. Now dew point pretty much says what it says on the tin, really: dew, moisture. The less moisture that's in the atmosphere, the colder it will be. and therefore any precipitation in the upper atmosphere will be freezing. Now here we're looking at the zero line here, which is represented by this line just over here, and if I follow that down you can see it goes all the way down here just north of Iceland. So that means that, as you can see, Greenland, this is 22nd of October again, deep shading, -30 here. I mean, this is seriously cold. This is why there's obviously ice over Greenland, because the ice is beginning to form now, so temperatures just drop away. So winter's setting up here now, and for us to get snow, taking in the other two factors of the thickness, so the thickness of the atmosphere needs to be much thinner, and also of course the -5 line I was talking about before, the upper atmosphere here, this one here. So if you got this, the -5, okay, covering the UK, so it will be green over the UK here, and then you've got the thickness, so you're behind the light blue line here, 528 line, so thinner the air, colder, denser. And then you've got the dew point, which is the moisture in the upper atmosphere, so that has to be greatly reduced, and it is behind this line here. The majority of the time we are behind the 10 line, so moisture in the atmosphere is greater, but up there of course obviously it's much drier air. So these three factors taken into account will give you the greatest chance of snow or precipitation falling as snow from the sky. Now the reason why when we forecast snow, and a lot of the time, you could say 9 times out of 10, snow turns up out of the blue. The reason for that is because this main factor here, this 0 degree line, can sometimes fall below while the precipitation is falling, therefore the rain turns to snow, or it reverses the effect. If it rises above 0, then the rain starts, snow starts to fall as rain. And that's when we talk about forecasters talking about rain, or sleet, snow turning to sleet, sleet turning to rain, as the dew point rises above 0. So I should have scripted this really, so I'm getting my words mixed up here, but what I'm trying to explain is that if you see snow falling and it turns to sleety rain, it's because the upper atmosphere dew point has warmed up. So once that goes above 0, you will get rain and sleet. So those three factors taken into account would give us snowfall. Not 100% guaranteed obviously, because there are marginals here, and obviously geographical locations, i.e. mountainous areas and so on, they can cause microclimates. This is more of a mainstream description really. If you live on a continent, i.e. America and so on, obviously these scenarios will be slightly different, but based on the same principles. I'm going to show you an exceptional chart now from 1987. I'll just show you that, so there you go, from weathercentral.d, and it's January 1987, January the 12th, and this was an exceptionally cold winter, in fact one of the all-time coldest winters we had in the UK in fact. Classic combination really caused by high pressure over Iceland here, over Scandinavia. Of course this goes in anti-clockwise directions, so it's dragging in bitterly Siberian winds from the east, and low pressure held out in the Atlantic here. So the jet stream has been, as you can see, it's diving south. This is the green line here, this is the jet stream here, that represents that. Now this is a cold pool of air just here. Now you've probably never heard of lake effect snow, and it comes from the terminology really of precipitation moving over the warm seas. Now obviously the sea temperature in January over the North Sea is not at its coldest, it's not at its coldest until March, spring sort of time really. So this time of the year you've got bitterly cold upper atmosphere winds here crossing the relatively warm sea in comparison, and you get precipitation as it hits the cold surface, comes over the cold land I should say, and turns that rain to snow, which is what we call lake effect snow. So it's precipitation turning into snow caused by the warmer waters below, which causes lake effect snow. So you can get a blast of easterly winds like this, and the sea can help produce snowfall. And this is why we tend to get what we call the beast from the east sometimes, when you've got a lot of bitterly cold air coming way back from Siberia, and then coming across the North Sea into the eastern parts of England, which is why central and eastern England tend to get the brunt of the snow. Of course, you're not always going to get snow from this, because if the air is very, very dry, you're not going to get a lot of precipitation forming. But lake effect snow can happen, and you don't need to have those key factors of the thickness and the upper air temperature and the dew points as well. Well, I hope that's quite explanatory for you, clearly explained for you. Just before I do go, actually, I've got one more chart here to show you, which is the upper atmosphere temperature at 850 HPA. And as you can see, we have minus 25 in the upper atmosphere here, minus 20 down here. So we are well within the minus 10 line. If you look at that line just there, that goes all the way down just here, and you can see, there you go. So that just shows you just how cold it was that year. And one thing I can say for certain now, it won't be getting as cold as this coming winter. But that's just an example of the three main characteristics you will need for snow to fall in the UK. That's the thickness being thin, thinner air, the dew point 0 or below, and the upper atmosphere at minus 5. So I hope that's clear. Obviously, you know, this winter's coming up, and I have been you know, blogging and posting and so on Twitter and various other social media, saying that this winter could very well be another cold one. The emphasis being on the first half of the winter being colder than the second as it stands at the moment, but many factors to take into account when you're looking ahead at weather forecasting, because there are more than just 3 events that need to take place to make it all come together. But anyway, that's my snow tutorial done for this year, I think. I may look at more historic weather charts for you in the past. I've got some really cold winters in more recent years, in fact going back probably to the 1800s, because these charts do date back to that particular era, so there are some astonishing winters back in time. We think they're cold now, but that's small beer compared to what they were way back in the history books. Well, that completes this snow tutorial for now, and check back to me soon.